Okay, so hello everyone. Nice to have you all here. As you can hear, my voice is still a bit rough. I couldn't speak for around a week, so my apologies for a bit of a weird voice. This is basically the first time that I'm talking again for like an hour, so sorry for my bit strange voice. Other than that, of course, we're going to talk about Alexa. You probably already knew that, otherwise you probably wouldn't be here. My name is Johan Janssen. I work for a company called InfoSport, so I don't work for Amazon or any other vendor of Alexa or any other voice recognition engine. Oh, let's mute it for now. If you want, you can tweet me or email me if you have any questions. So basically, what are we going to do in the next 45 minutes? Basically, this is the content we're going to discuss. I put questions at the end, but if you have like a short question in between, please feel free to ask it immediately, and I'll try to answer it immediately. You don't have to wait until the end. So basically, what's the Internet of Things? Often what we see is that it's something involving like a CPU, some chips, some wires, next slide, some wires with communication. But unfortunately, I see that lots of stuff nowadays is branded as IoT simply because it sells better if you put the term IoT on top of it. I attended a presentation about quite a nice living room light which would change colors based on the humidity or the temperature of a room. So normally those things you note it as digits, like it's 21 degrees Celsius. But they wanted to show it in colors for people who cannot read or have difficulties understanding numbers. And I thought that's a really great idea. And the session lasted for about an hour. And towards the end, somebody asked, like, yeah, but this is an IoT session. What's the connection? How is it connected to the internet or something else? And the presenter answered, oh, it's just running on its own. It doesn't have any connection at the moment. Oh, and the colors, they basically just changed randomly. So basically, I listened to like a talk of an hour, branded IoT, but it was just a living room LED changing colors, which you can buy on the internet for like $5. And so please be aware, if something is labeled Internet of Things, it doesn't mean it's cool and hip. Some people try to misuse it to sell their garbage. Some term that I found was like Internet of Things is the infrastructure of the information society. And yeah, often IoT stuff involves some infrastructure, some communication. So how does home automation fit in? Who of you automated some parts of their home? Okay. Do you use a smartphone for it? Who uses a voice recognition engine for it? Oh, cool, already quite some people. So often you see people connecting to their smart home with a smartphone to control the lights, the temperature, etc. So what other things can we control instead for just the lights? I have a colleague who I think created quite a nice example of what you can automate in your home. My colleague basically has 2 rooms, a living room and a bedroom, and only 1 television. I found this quite amazing. He could control it from the Netherlands while his home is in Belgium. That's a really great idea. Although I think buying 2 TVs would have been cheaper. But this can have extra benefits. So, for instance, I asked him, can you spin it around quickly? Because then you can also use it as a fan. But he didn't try that yet. So basically, we can automate almost anything with home automation. So for me, home automation is like a subset of IoT. It's like the things that you do in or around your home. So what challenges do we have with home automation? Sometimes we have to charge our smartphone. And if we use our smartphone, we then cannot use it to control our smart home. And I think with this phone, you have some other challenges. But smartphones tend to break, and then you cannot control your room anymore, or they get lost, and you cannot control your home anymore. And one thing that's quite important for me is when you're having dinner, sometimes, at least in our family, we have a discussion and we don't agree on it. And of course, I could use my smartphone to look for the answer, but that's considered impolite, and my dinner would get cold. So it's not really a good solution to use a smartphone for this. And what if you're relaxing and your smartphone is not near to you? Then it's a bit difficult because you have to get up, get your smartphone, continue. So for me, smartphones, they're a bit like Batman. They were cool in the past, but they had their best days. And nowadays, we have better solutions, like, for instance, Amazon's Alexa voice recognition engine. So what's Alexa? Alexa is not like a woman who is answering all your calls, because then she would have to be really fast, or there would have been a lot of Alexas. It's basically like a cloud service. So I say something to the device, and then the Amazon cloud can handle all kinds of requests. So what can it handle? For instance, if I say to Alexa, play TuneIn radio.
Getting the last TuneIn station you listened to, 538 Dance Department.
Alexa, Wikipedia, Java programming language.
Here's the Wikipedia article on Java, the programming language. Java is a general-purpose computer programming language that is concurrent.
Stop. Alexa, stop. I won't bore you with the entire Wikipedia article, because then probably this session would have been passed already. And so I can do multiple commands. I can do like things like music. I can use Spotify on it. I can ask it questions for Wikipedia. I can, for instance, ask Alexa, who won the actor for Best Actor in 2012? Sorry, Alexa, who won the Oscar for Best Actor in 2012?
Jean Dujardin won the Academy Award for Best Actor in 2012 for The Artist.
So if you would have a discussion like who won the Oscar, you can easily ask it Alexa without having to grab your smartphone. So I can basically ask it any question I want, such as what's the weather, or really practical stuff like Alexa, where is Chuck Norris? Oh, Alexa, where is Chuck Norris?
If Chuck Norris wants you to know where he is, he'll find you. If he doesn't, you won't know until it's too late.
And so lots of useful things you can do with it. In the beginning, you could also ask it, Alexa, where can I hide a dead body? And it would say, bring it to the police or something like that. But that doesn't work anymore. Maybe it's not politically correct anymore. For me, like the device, I didn't think it was really interesting because you buy it and it works, and I'm a technician, I like to play around with stuff. So I was more interested when they announced that you could build those devices yourself. They basically released the software running on a device like that. And you can do that with like a Raspberry Pi, a microphone, a speaker, which you see on the screen. And then you have it completely running yourself, or you have basically the home part running on your own device. It will still connect to the cloud to get the answers to your questions, of course. So I really like this. I set it up and everything. I actually included a touch screen, so I could use touch screen to do stuff. And for instance, if I ask Alexa for the Wikipedia article on Java programming language, if you have a screen with Alexa, you also get the article in text, so you can easily see it. The same goes for the weather and stuff like that. So with this guide, you could easily configure your own Raspberry Pi with Alexa, which is really cool. Unfortunately, like when I started with it, the devices from Amazon were still quite expensive, like 150 euros or something like that. And with a Raspberry Pi, I built it for like 80, 90 bucks. Unfortunately, like 1 or 2 weeks after I finished my project, they released a new version for 50 bucks, which is a bit of a pity. Because the new version is actually, it's much better. I use one microphone, and this small device from Amazon has like 7 integrated microphones with noise reduction techniques and all kinds of fancy stuff in it. And so, would you either build it yourself or buy one off the shelf? If you don't want to spend too much time, buy one off the shelf. If you want it cheap, buy one off the shelf. If you want to fiddle around with stuff and have like maximum flexibility, this, by the way, is my daughter, who is here for the first time to attend my presentation. So I hope she likes it. Somehow. And so you're really flexible with building it yourself. And if you're concerned about privacy and Amazon listening to stuff you're sending, then of course, I mean, it's just Java code which you can analyze and you can implement your own solutions in it. So you have more control on what's happening than on a custom machine. But if you want to start quickly, off the shelf is a lot easier. So what can we do with home automation with Alexa? So actually, this is a movie a colleague of mine made.
Hey Amazon, trigger open the sunscreen.
Sending that to IFT.
Hey Amazon, trigger close the sunscreen.
Sending that to IFT.
Hey Amazon, turn on all the lights.
Okay.
And so basically what you see here, my colleague had the device which is in front of him, it's just a tablet, which he used to control his smart home. He used openHAB for it, a home automation software based on Java, which I will show in a second as well. He already had the solution with the tablet, and what he did was he integrated Alexa with the tablet, or with the openHAB solution basically. So with only like an hour of work, he could basically replace his smartphone or his tablet with voice commands with Alexa. To open his sunscreen, to control the lights, basically to control everything in his home. So openHAB, you can completely customize the UI and basically add anything that you want to automate with your home automation. I couldn't bring a sunscreen because it's fairly big to bring, but I brought something simpler, and this is like a smart plug, which basically I can control it remotely and either put the power on or put the power off. So when it's green, the power is on, and now it's not green, and then the power is off. So let's try if it works. Put this out. So if you look at my charging icon down here, it will probably go off in a second. Alexa, trigger switch off.
Sending that to IFT.
Of course, the demo effect. Alexa, trigger switch off.
Sending that to IFT.
So now you can see it's off. Might be a bit delayed because it's crowded and lots of people with Wi-Fi and stuff working here. Normally it's instant if I do it in my home. So this way I can basically control things in my home which are connected to a power cable. And I do that by using if this then that. Let's just show the website immediately. So this is my simple openHAB solution. And you can see that in the website it also changes. So now it's off, and if I say Alexa, trigger switch on.
Sending that to IFT.
So it will go on in my interface as well. So it's synced both ways. That works quite well. And if this then that is simply a service to connect two things together. So in my case, I connect Alexa with openHAB. Or in my case, not openHAB, but my TP-Link switch. So if I say the phrase switch off, then basically my switch will be turned off. So with if this then that, I can couple lots of different things together. I can also say that if I add something to my shopping list with Alexa, that it will get an email with my complete shopping list. Things like that. You can couple all kinds of things. SMS, apps probably as well. So it's really convenient. You don't need to program stuff. You just basically bind it together. So how does it work? If we go a bit to the front, I have my Amazon Echo Dot. It connects to the Alexa cloud. From the Alexa cloud, it connects to if this then that, which is also running in the cloud, which runs to my openHAB, which is an openHAB service in the cloud again, which allows me to connect to my local openHAB instance running on my Raspberry Pi, which then connects to my TP-Link switch. So quite some connections, quite some cloud environments connected together. One of the first times I demoed this, the creator of openHAB was in the room as well, and he asked me like, yeah, weren't you scared that it wouldn't work with all the cloud environments? So I asked him, why? Are you afraid your service is not available? Everything worked, of course, a little bit of delay, but it works quite well. And so by using these kinds of things, I can quite easily automate stuff, but I can even go a bit further than that by creating my own skills. And with my own skills, I can do all kinds of stuff. So I can retrieve information, I can order pizzas. So skills are a bit like apps on your smartphone. You can create them, you can use them yourself, or you can publish them so that everybody can use them. So there are some skills available already where you can order stuff, but you can also create things yourself, like I said. So how does it work? Basically, we go to the Alexa environment, and then we connect to a skill. And actually, there is now an openHAB skill. So I can use the openHAB skill to directly connect to openHAB. I don't need to use if this then that anymore. But I like the example, so I kept it in here. So how do skills work? Basically, we use the wake word for Alexa, which is Alexa in my case. You can also choose computer or something else. My neighbor, or my colleague who made the video, changed it from Alexa to computer because the kid of his neighbors is called Alexa, and yelling Alexa stop was quite strange. So he changed the wake word. So you can choose like 3 different wake words. After the wake word, you basically call the name of your skill, which we will call the invocation name, and then we call an utterance, basically what we want to say to our skill. For instance, hello. Underwater, those utterances are mapped on intents, and based on an intent, we can program some stuff. So let's simply look at a piece of code, which maybe makes it easier to understand it. Is this readable from the back? Let's see if I have the right one. I think this is not the right one. And this was the right one. So basically what I have here is the invocation name is hello. So my skill name is hello. And I can say 2 things to it, hello and hi. And both are mapped to a hello world intent. So if we look at the code, we have a stream handler, which is basically quite default code. And we have a request handler, which implements the request handler. So basically, Amazon gives us an SDK which we can use to program stuff. So in this case, I say that this handler will handle output which matches the hello world intent. So if we look back, hello and hi match the hello world intent. So if I say, Alexa, ask hello to say hi, it will match the hello world intent, and it will then execute this piece of code. And with speech text, basically is the text that I will return, which Alexa will talk to me. And simple card is what we can see in the interface I will show you in a second. So if I tell to Alexa, so I say, Alexa, ask hello to say hi. Oh, Alexa, ask hello to say hi.
from my first skill.
So that's what's written here. And if we look at the web interface, or if we have an Alexa device with a GUI, we could see this immediately. But in the web interface, so alexa.amazon.com, I can also say what I'm saying to Alexa and what the return is. No, I'm not saying something now to you. So basically, I can check if something is right over here. So the funny thing is that, and what's shown there, I can customize with saying with simple card, hello world, speech text, and I can add anything I want here. So what's the cool thing, what I like about it is, to implement voice recognition, the only thing I needed to do basically is specify some stuff over here and write like 5 lines of code. And then I have my own voice recognition service, and I can do with it what I want. Of course, this is a really simple example, but you can make it more complex, as we will see later. Those skills, if I created them, I can deploy them either in AWS Lambda, which Amazon, of course, likes because then it's in their cloud. But I can also run it as a local web service, or a web service somewhere in the cloud, on Google Cloud, Azure Cloud, doesn't matter, and I can connect to it. I can write those skills in Java, but I can also write them in Node.js, Python, or a lot of other languages. And what happens when I build a skill myself? Basically, I upload the skill somewhere. In my case, I upload it to AWS Lambda because I like it. It works quite easily. I can just upload my jar file and then it runs. In the Amazon developer account, I specify what the name of my skill is and where my application in AWS Lambda is running. And then through the Alexa cloud, basically, my skill is being used. And we'll show you in a second how the complete flow works. So normally, we would do something like this. We would deploy a jar file by hand in the web interface of AWS Lambda. And if I have a new version, I simply upload the jar file again. But of course, that's a bit tedious if you have to go to a web interface every time that you have a new version. Because so I can create a new function, which basically is an AWS serverless application. And then I can specify here, basically, it's a Java function, some name, create function. So I could do this, and then I could upload somewhere, let's see where it is here. I can upload a zip or a jar file with my application, and then I can run it. But for me, that feels a bit like a lot of work, and a lot of work I don't like to do. So let's immediately go to the next phase where we try to automate a bit more stuff. But first, one thing to keep in mind is we run our application in AWS Lambda, and we connect our skill to the application. So basically, the application is just an application. We create a skill which connects to the application. But basically, everyone can connect to our application if we don't secure it. So if you want to secure it, what you do is in the application, you configure the skill, and you also enter the skill ID. And then that ID basically couples it to the skill that you created yourself. So then only your skill can access your application, and no other skill can use your application. Because else you might have to pay for somebody else who is using your skill. So this is quite an important security measure to take. Next step I've taken is to basically make automated deployments with Maven. So I no longer need the web interface. And to do that, basically, with Maven or with Jenkins, I can say, OK, I have a jar file, upload it, and then it will be uploaded to an Amazon S3 bucket, which basically is storage in Amazon. So we have to set up that S3 bucket once, only once, then it's OK. If I create 10 new skills, I will still use the same bucket. and I have to specify an AWS role, again only once, and that role is used to create basically an application from the stuff you have in your S3 bucket. So we have to configure two things only once, and then we can automatically deploy our application. And so to give a complete example of it, let's simply copy and paste the Hello World example, which we have. So this one. And we call it something like, TEQnation. Change this as well. TEQnation. And so this is my Maven plugin, which I use to deploy my application to AWS Lambda. So I specify the name of my skill, I specify things like timeout, memory size, and that it should be triggered by an Alexa skills kit. So this is some configuration I add to my POM file of my Java project. And then I have the project in here. TEQnation. So I simply, oh wait, let's add some text in it because else it's simply saying the same as before. Hello world. Let's simply say hello TEQnation. And we also changed the model so it will listen to nation instead of hello. TEQnation is a bit difficult for Alexa to understand. I tried it but failed miserably, so let's just keep it simple. So I create my jar file and then I deploy it. I don't show the deploy script because in there basically my credentials are included to connect to the AWS cloud, so I don't want to show that to you. But in a second this will be deployed to AWS Lambda. So let's see over here if it's already there. Of course, always nice demos. Let's see. So now we have a TEQnation skill over here. So basically, I call it a skill, but it's not really a skill yet. It's just my application that I've deployed in AWS Lambda. And now I have to create a skill. And I do that in the developer portal of Amazon. So here all my skills are included. So I basically create a new skill. I call it TEQnation. Simply a custom skill. Yep. And I copy and paste the stuff that I have in my JSON over here. I copy paste it over here. So basically Amazon needs to build like what they call a model of what I can say to my Alexa skill. So basically this defines the interaction with my skill. It takes a little while before it's being built. And then I couple this skill to the application that I deployed in AWS Lambda. And normally so the extra step for security measure would be that I retrieve the ID from the skill I created here, then put the ID in my source code, upload the application in AWS Lambda, and then they are tightly coupled together. But I skip those steps for now because it takes a bit of time. But normally I really do this. Now I can test my application by saying that I want to test it with development. And then Alexa, tell nation to say hi.
I'm not sure what went wrong.
Alexa, tell nation to say hi.
Hi.
Alexa, ask Nation to say hi.
Sorry, something went wrong.
Alexa, ask Nation to say hi.
I'm not sure what went wrong.
Did I put in something incorrect? Let's see. Sorry? No, it doesn't really matter. The hello world intent is basically, I can name it anything. It doesn't matter for how I call it, but thanks for the suggestion. It's called Nation here as well. Alexa, ask Nation to say hello.
I'm not sure what went wrong.
Alexa, tell Nation to say hello.
I pronounced that hello, but I'm always working on how I say things and I might not have it right.
Alexa, ask Nation to say hi.
I'm not sure what went wrong.
Alexa, tell Nation to say hi.
Hi.
I don't know, like yesterday it still worked, but I forgot to change the rest of the text, is it that? No. No, so normally this would work and it would return hello TEQnation. It worked yesterday, but apparently I did something wrong, or because of my pronunciation at the moment, Alexa cannot understand me. What might be nice if we are still looking in here is to see a bit more advanced example. So I have created a bit more advanced example where I can also ask about colors. So I can say, Alexa, tell demo the color is red.
You picked the color red.
The color is blue.
You picked the color blue.
The color is black.
You picked the color black.
Which is strange, right? Because I defined a color intent, and I can say the color is some color, which is a variable, and I specified a list of colors which is available. And it only included red or blue.
You picked the color available.
Yeah. So what happens here? Stop. It stopped already. So what happens here? Basically, the list of colors I specify here is like an example list. Any color that sounds the same will work. So if I would have said the color is light blue, it wouldn't work because it's light blue. But if I would have added light blue over here, and I would say the color is dark red, then it would work again because it's two words. So these are basically sample words which we can say. It's not like a finite set of things we can say to Alexa. And another interesting thing you might have noticed is I say which should end session false. And that basically means I don't have to say Alexa blah 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 every time because I create a session with Alexa. Alexa keeps on listening to me, so I can basically only say the things that I want and not use the wake word because Alexa keeps being awake, basically. So I'm in a conversation with Alexa. Let's see. This one we already had. And another interesting thing is that I have a cancel and stop request handler. I see there are some other voice recognition engines in the room, which I define here as well. And those cancel and stop intents, I can use them if I have a conversation with Alexa to stop the conversation. Like if I say, Alexa, the color is blue.
Blue is one of the three primary colors of pigments in traditional color theory.
Alexa, stop. Alexa, tell demo the color is blue.
You picked the color blue.
The color is red.
You picked the color red.
Stop.
See you next time.
And so basically, I have the cancel and stop request, and I say see you next time if I say either stop or cancel, and then I'm out of the session. So this way I can basically program around. I can use variables in my code. I can basically do anything that I want. And to show you that you can really do basically anything, I created an extra example which connects through my skill, and then it connects to a Spring Boot application running in AWS Lambda. I need an API gateway basically to get like a REST endpoint to connect to my AWS Lambda application with Spring Boot. So is this a good solution? Probably not, because Spring Boot, it takes a while to boot. And those skills in AWS Lambda, after like 30 minutes of inactivity, they're passivated to disk. So then if you call them again after half an hour, they need to boot up again. And typically a Java or a Spring Boot application, it doesn't boot quickly out of the box. So you have to take that into account. If you have a request more than once every half an hour, it's of course no problem because it's active all the time. Otherwise, it takes some more work. So let's show you how this works. So basically, this is still all the Amazon Alexa SDK. So in the Amazon Alexa SDK, there is an API client request and an Apache HTTP API client, which I can use. So basically, I use an API client from AWS Alexa. So Alexa SDK provides this, and then I connect to a Spring Boot application running. And the Spring Boot application running is this one, which has some extra configuration to run within AWS Lambda, but for the rest, it's simply a REST endpoint with hello. So let's see if I can call this. Alexa, tell demo the name is Johan.
Skill hello John.
Almost Johan, it's English. So basically, I created all this to show you that you can do anything which you can do with your normal programming languages. You can use it to build your skills in Alexa. So you can do anything you basically want. You can connect it to your REST endpoint, you connect it to your openHAB, it doesn't matter. I had one other thing. I can quickly test if it's working, but for whatever reason it failed since yesterday, which is a bit of like difficult because it's all in the cloud and you're not fully in control, so sometimes things change and then your demos don't work anymore. Oh, it's booting. So what I basically did is to test your Alexa skill, I of course can write unit tests, but it's a bit useless because it's not only my small application, it's the entire configuration that I need to basically run everything. So what I did is I basically let two Alexa devices talk to each other. So they talk to each other to test each other's skill, basically. I can quickly see if it's working now. Ask tester to start. Ask tester to start. Ask tester to start. Okay, not the best day for demos apparently. So normally they would talk to each other, and yesterday they talked to each other but a bit too quick, so they couldn't understand each other quick enough. So I had some issues there, but it won't start now. But I mean, this might be a solution if you want to test your Alexa skills, but it requires some time to set up everything and make it work. If you want to get started with this stuff, simply look at either my examples or the examples from Amazon already. So if you want to create a new feature for Alexa, you have lots of options. You can either use an existing skill, integrate it with if this then that, or create your own custom skill. Disadvantages, it still needs to grow, to mature. For instance, the regions, it doesn't support Dutch at the moment. It supports German and other languages, but no Dutch. If you have a bit of an accent, or if you have a bit of a cold, it makes it difficult to use it. And one thing I particularly noticed is, it ignores you. So if you type something incorrect in Google, it doesn't really matter. Google still finds the answer you want. No matter how many grammar errors you make, you get the right answer most of the time. With Alexa, it simply ignores you or gives you some really strange result. Some dark clouds, mainly privacy and security. So one of the things with Alexa is it doesn't distinguish between voices. So my daughter, she can say, Alexa, order last pizza again. And she can say that 10 times. And I will get 10 pizzas. And my credit card is charged for 10 pizzas. So that's a bit of a disadvantage. I hope she doesn't hear it. Advantages, it's new and cool, of course. But I think it's also really useful. And it's really practical within families. My colleague, he brought it home, and his wife was like, oh no, another gadget. Why do we have to use it? Get rid of it. And he was like, no, we just try it. And I think he had it for like 2 weeks before he had to return them to me. And then his wife said, can we buy one ourselves? Because it's really useful. And so you get used to it really quickly, and it works really nice. So I don't know if it's the death of the smartphone, but it will replace lots of the functionalities that we now use our smartphones for. So up to the conclusion, I think it's relatively easy to integrate. It's a nice way to develop some software. If it's in Java or Python or whatever language you like, it doesn't really matter. And you quickly get used to it, and it's lots of fun. You can use it for lots of applications, basically. Questions? I think time's up, or do we have some time for questions? Okay, so are there any questions? Yes? In which one? This one? No, sorry, I didn't say it correctly. So the speech text is what Alexa will tell to us. It will speak it. And the simple card is basically this. So it didn't reply, it didn't tell me the text at the top, so it wasn't working. So this would normally be told out loud, basically. And the card is basically some extra information. So that wasn't the issue. What's the issue? I can try it again. Alexa, tell Nation to say hi.
I'm not sure what went wrong.
No. I don't know what the error was. Yeah, this basically all the code in here doesn't really matter because it responds on the invocation name. And all the rest, I can name it whatever I want. It shouldn't really matter. So I'm sorry, I don't know what's wrong here, but most of it looks okay. Maybe my deployment somewhere failed. No, I know what's wrong, basically. I didn't connect it. I told you I needed to connect it to my skill, and then I forgot to do that. Sorry for that. So I didn't make the connection between my skill and my application. So if I try it again, Alexa, tell Nation to say hi.
Hello, TEQnation.
So you have to keep in mind that you configure stuff correctly. The advantage is you normally do it once, and then when you update it, you only basically do the Maven deploy command, and all the rest is already set up for you. So that's like only one-time setup for your skill. So I would say thank you all. If there are any questions, feel free to approach me later, and thank you all.